Afternoon. Am I visible and audible to you?
Yes, sir. Good afternoon.
Perfect. I am speaking from our office in Rotterdam, in the Netherlands, and our session today, which will be 25 minutes, is mainly aimed at Q&A surrounding the new chimney design, a special chimney design that is being proposed by our company as a very effective and economical chimney design for FGD projects. We have prepared a very short presentation. Clearly, the main objective is Q&A, so please do not worry. We will not take much time, basically 5 minutes only, and that will be a quick reminder of what the new chimney design is, and then we would like to make ourselves available for answering any questions that may be there. So
let me just introduce you first, Mr. Kreij, and after that you can begin.
Please.
Yes. So we have with us today Mr. Albert D. Kreij, who's Sales Director at HADEK Protective Systems. In 1989, he joined HADEK Protective Systems, which specializes in the internal protection of power plant ductwork and chimneys. During his tenure, he's gathered experience in the use of thin film lining systems and borosilicate glass block linings for ductwork and chimneys. He's also undertaken a number of technical studies on the use of these linings and is also involved in the practical aspect of these lining systems. So we are ready for this very short 5-minute presentation, and after that we'll take the survey questions.
Perfect. Okay, so we will take over the screen now and start this presentation.
Right.
Could you confirm that it is visible to you?
Yes, sir.
Perfect. So, first of all, as of course we had mentioned, the objective of our time today is to answer any questions that might be there about the new chimney design, which we are proposing for FGD projects worldwide, but certainly also in India. And before we go into the details of the new chimney design itself, I would like to quickly reiterate the main properties of the lining system, because this is a very key part of the new chimney design. So, as you may be aware, our lining system is called the PENNGUARD block lining system, but it is the nature of this lining system is that it is a closed cell borosilicate glass block lining system. The lining system is already used in India, although not yet in the new chimney design, but worldwide we can consider this as a very well introduced and well-known lining system, both in conventional chimneys and also in these specific new chimney design chimneys. So very quickly, the lining system consists of blocks of closed cell borosilicate glass. They are acid resistant. They do not allow the entry or passage of acid. They are impermeable, and they are glued to a substrate using a special type adhesive. They can be glued to steel, but also to concrete, which of course we are talking about in the case of new chimney design. Very important. It protects not only against acid, but it also protects against high temperatures. And of course, in the case of the new chimney design, please keep that in mind. It is a very key property of the lining system as it helps to prevent thermal stress in the concrete. So, what is the new chimney design basically? In very simple words, it is a concrete shell with the lining, the borosilicate glass lining, glued directly to the concrete shell. There is no steel flue. It has been developed about 15-20 years ago, specifically for power plants with FGD. So it is for operation with mainly with low temperature flue gas, although some of them do actually operate with high temperature flue gas as well. And of course, it has special technical and economical advantages. That is quite simply spoken, they are faster to build and they are lower cost to build. Both of these advantages will be highlighted in the rest of this session, of course. So here is a schematic view of what it looks like. Of course, we have the concrete shell. Depending on the design of the chimney, it can be typically between 40 and 20 centimeters thick. And the lining is applied directly to the inside of the concrete. The basic thickness that we recommend is 5 centimeters, to be more precise, 54 millimeters. But in specific cases, we can go also with our reduced thickness of 41 millimeters, but this has to be evaluated by our technical people from case to case. Very quickly, a sample project. This was in fact one of the first projects that we did with the new chimney design. We are looking here at a power plant with 4 units of 200 megawatt. They were under legal obligation to fit FGD. They're old chimneys. You can see them here on the left side of the picture. They were not suitable for FGD operation, much less for even for wet stack operation. So they needed to build new chimneys. What they decided to do was to build FGD plants, 1 FGD plant for 2 units. So you are looking at the yellow absorbers there. They are each connected to 2 units, so they cater for a total of 400 megawatt capacity. And each of these FGD systems, wet limestone systems, has a separate stack, which is a new chimney design chimney. I'll quickly go to a close-up of the system, and here you see one of the FGD plants with its own chimney, 150 meter high, roughly 8.4 meter diameter. It is a wet stack. As you can see, this owner has made a maximum use of the compact layout, where he builds the FGD system and the chimney very close together, and there is only one very short outlet duct which crosses over at a level of plus 43 meters. So not only do they have a very good low-cost chimney, they also have minimized expenditure on their ductwork. So it's a very compact and economical setup. Before we go to the questions, 2 more things, actually 3 more slides. First of all, it's important to understand that new chimney design is an advanced technology. It is an advanced design which we offer together with our design partner from Germany, a company called Constructure from Düsseldorf. But actually, the construction of the new chimney design can be done by local concrete constructors all over the world. So here we see the construction of the PATNOW chimneys in this case. They are slip formed, and this slip forming technology is widely available. So even though the design is an advanced design, the construction can be done with local partners in India, and also the lining itself can be done by local contractors in India. Here we see some pictures from this project, PATNOW. There is, like on all projects, there is a suspended platform with the workers installing the PENNGUARD from bottom to top. And you can see a close-up picture on the right side, and that is where you see how one of the workers, in this case Polish workers, installs the lining onto the concrete. By now, our company is gathering a lot of experience also in India. We are starting already our 3rd project, and we are finding that the use of our lining system under our supervision, technical supervision by our inspectors with Indian crews is very successful. Final sheet. And this is more of a conceptual sheet, but it is an important idea that we would like to show to our customers. Many customers believe that it is lower cost to build a twin flue chimney for 2 units than to build separate chimneys. And here we compare the two, just for thinking. On the bottom, we see the model of a twin flue chimney, and you can see that this chimney is actually more expensive because it uses more concrete volume than the two single chimneys, and of course it has the steel flues, which are very expensive, and also it uses long ducts. If we go to the model which is shown on the top, and which was actually used at PATNOW, which we just saw, where one chimney is used per absorber, the whole layout is much more compact, with a lower cost for the chimneys and far lower cost for the ducts. Of course, we are seeing that our customers in India follow this line of thinking very well, because typically on projects in India, we do indeed see one absorber with one chimney. So this is already seen in many projects in India. Of course, we would like to suggest that by going from a classical chimney with a steel flue over to the more advanced new chimney design, a lot of money can be saved and a lot of time can be saved. So this was just my introductory reminder presentation. And of course, this is a Q&A session, so if there are any questions, we'll be very happy to deal with these and hopefully provide a good response.
Thank you so much for sharing the presentations. So we'll move to the questions now, I think. Let me just begin by asking the questions which had been shared by the participants over the course of last few days. So I will just begin one by one. The first question is that this has come from L&T Power. If we install wet chimney with necessary liner, then whether the same chimney can sustain for prolonged cycle operation under bypass condition of FGD? If so, then what will be the probable side effects?
Yes. So there are no expected side effects from such type of operation. We have quite a few customers historically who start up their power plants nearly on a daily basis in a so-called two-shifting regimen. And typically these startups are done in FGD bypass mode. So these chimneys go in the morning as they start up. They see a short period of operation with 130 degrees C, and then they drop down to a much lower temperature resulting from FGD operation. We have tested our specific lining system for withstanding 1,000 cycles of going up to 160 and then down to ambient temperature in a quick cycled fashion, and we have found that it doesn't result in any damage for the lining system. So briefly, my answer to the question should be it is indeed possible to run FGD bypass operation even if it happens frequently.
Next question is, how can the new chimney design save about 30% construction cost and space required for construction? And
Yes.
how is it possible to save 5 months of chimney construction time?
Well, quite briefly put, if we compare the new chimney design to a chimney with a steel flue, both of these chimneys can do exactly the same. Both of these chimneys can have a lifetime of more than 30 years, except in the case of the new chimney design, we have completely eliminated the steel flue. And if I look at our projects worldwide, but certainly also at our projects in India, we are seeing that the construction of the steel flue is extremely expensive and extremely time-consuming. So certainly because the standard design that we see in India is based on using quite thick steel for high dependability, which makes these flues very heavy and it makes them bottom supported. And so the process of building these steel flues is a painstaking process, which is both slow and expensive. So this is the number one reason, the elimination of the steel flue, saving both cost and time. The second very big advantage is that we can shrink down the volume of the concrete shell. So in accordance with Indian construction codes, the opening in the shell can be only a small percentage, if I'm correct, only 20 degrees of the circumference. And so when you have to enter through the bottom with a steel flue, you have to make a very wide, very tapered bottom of the chimney. By eliminating the steel flue, this requirement is completely eliminated. So we can make the concrete shell far more slender. This is also a huge cost saving.
Right. These questions were from BHEL. So there was another connected question. Is there any guarantee on concrete construction part also, apart from borosilicate lining system?
Yes, our company provides, and I'm sorry I have to go to commercial points, even though this is a technical meeting. Our company offers a full 10-year guarantee on the lining. So when we supply this lining, which is a high quality product, and we supervise the installation, we give a 10-year guarantee. Now, in the case of the new chimney design, many customers are quite critical, and they say the lining is fine, the lining will hopefully and probably withstand 10 years or 30 years, but how about the concrete? Can the concrete be also fully protected? And that is why our guarantee to our customers is that if they use the new chimney design, that the width of the cracks will be always limited to less than 0.2 millimeters. This is only possible when using a high-quality lining system. Unfortunately, we have seen some cases where low-quality lining systems were used on concrete, where these lining systems were attacked by the acid. They lost their insulating capabilities, and so the concrete was exposed to high thermal stress and to wide cracks. So in order to reassure our customers that this can never happen with our lining system, we add into our guarantee for the new chimney design 0.2 millimeter maximum concrete crack width.
Okay. Next is from Hindustan Power Projects. Is there any other design criteria in addition to conventional one for cost-effective design of chimney? And can you give a comparison of chimney lining, borosilicate versus others?
Yes. So first of all, of course, the number one point that needs to be considered is thermal stress in the concrete shell. By using a proper lining system, this thermal stress is strongly reduced, and by using a sufficient amount of hoop reinforcement in the concrete, the remaining stress can be easily dealt with in the concrete shell. Our design partner is, of course, who I mentioned, Constructure, is fully experienced and has the ability to do this in their design work. The other design criterion that we consider as very important is that any new chimney design should be fully cylindrical or cylindrical to the greatest possible extent. We have seen some customers worldwide who have tried to emulate the new chimney design, and they ended up with a design that was strongly conical for, as they felt, stability reasons. A very good design can only be a cylindrical design because two reasons. The amount of lining material, which is the expensive item, is greatly reduced by going from conical to cylindrical. And second, and very important, if you want to run a conical chimney in a power plant, you will face very high operating costs due to the pressure losses, because basically your booster fans will have to work very hard to push the flue gas through the inefficient conical chimney, and this is a hidden cost for power plant operation that will be significant over the lifetime of the power plant. So, long story short, we feel that every new chimney design has to be as much as possible, preferably completely cylindrical in shape.
Okay. Next is from AP Genco, sir. If you could advise regarding minimum distance which may be kept between old and new FGD chimney and the factors that should be considered while designing this distance, because they had proposed in their tenders a 50 to 70-meter distance. However, in the pre-bid meetings, the bidders have advised them to keep a minimum distance of 150 meters to safeguard the old chimney from wind pressure. So what are your thoughts on this?
Yes. So this is a very specific problem, and it is not possible to just say a certain distance is safe and another distance is not safe. It has to be studied specifically. We have quite a few projects where there are multiple chimneys close together, 50 meters apart, and there is no problem at all. And we have had other projects where chimneys are much more apart than 50 meters. They may be 150 meters apart, and it is a problem. The problem is that if one chimney creates a so-called vortex shedding, where a regular turbulence is formed, which is then going towards the other chimney due to prevailing wind direction, this can create shaking, it can create vibrations in the affected chimney. So we would recommend to do a specific study for each project. It is quite possible that putting the chimneys close together is no problem at all, and in any case it is necessary to review it. Now, if there is any shaking in an existing chimney, it is possible to remedy that by putting weight on the top of that chimney. We have seen cases in the past where that was done. One project in England where a new chimney was built next to an old chimney. The old chimney started shaking, and then there was a special construction was placed on the top of the shaking chimney, and that's why the problem was solved. So I would not work with rules of thumb, that would be my recommendation, but with project-specific evaluation.
Mm-hmm. And next question is, sir, that what is the life of this PENNGUARD chimney, and what are the periodic maintenance kind of requirements and procedures along for wet stack?
Yes. So the service life that we can see is more than 30 years. Now, again, this is based on using the high quality lining system and full on-site inspection during installation, 30 years. Yes, of course, it is always recommended to check the condition of the lining system. But basically, we have no fixed requirement for it, so we will not compel any customer to check his internal lining system. That is not a contractual requirement. However, we have now developed a new technology that allows our company to assist customers in checking the inside of their chimney. Basically, what it is it is a self-operating drone which can be operated by one of our inspectors from the bottom of the chimney that moves up and down the chimney with a special lighting system and special camera system, which will result in 4K level comprehensive view of the chimney. This makes it possible to make a full inspection of any chimney within 1 or 2 days, so well within the length of any maintenance outage. We would recommend, it's only a recommendation, but we would recommend to do it in year 2, year 6, and year 10 of the lining life. And in fact, our company will offer that as part of its guarantee. After that, from year 10 to year 30, of course, it's optional to do further inspections using this same drone method. But of course, there will be a cost involved.
And can this be applied for twin flue chimney as well? And if so, what are
Yes.
the kind of costs involved? What is the cost of twin flue wet stack for a height of 180 meters?
So I don't want to mention any figure for a wet stack of 180 meter with twin flues. We could probably go into the history, but this depends very strongly on the labor market. It depends also strongly on the availability of contractors to place this into their time schedule, and on the cost of materials such as steel and concrete, which can also vary. But basically, on a fundamental level, definitely yes, our lining system can be used in a twin flue chimney. We have many twin flue chimneys, 3 flue chimneys, 4 flue chimneys even. Of course, in that case, the new chimney design is not applied. There will have to be steel flues, and these steel flues can be internally lined with our technology.
Mm-hmm. And what is the basic material constituent of PENNGUARD?
It is borosilicate glass of a special composition. Borosilicate glass is a well-known product. It is used in all types of applications. In the type of our lining system, it is a very specific composition, which is based on using only new products. No recycled glass may be used, and which has a hydrolytic resistance of class 1. Now, this sounds very simple, a hydrolytic resistance of class 1, but actually, to achieve this hydrolytic resistance of class 1, for high volume production, because please keep in mind that one chimney may use 50,000 pieces of block and they all have to be good. To have such a high quality on high volume requires a very specific production method. So that's the best way I can describe it. It's high purity borosilicate glass of class 1 hydrolytic resistance.
Mm. And do you design the flared design at the top of the chimney for reducing the pressure losses?
Yes. Well, there is one concept which has been developed by our company in cooperation with Constructure, and it can be applied to the new chimney design which we were talking about, and it is the so-called diffuser. We have a little video on our website about that, where you can see how making a top diffuser on a chimney, maybe 15 meters high under an angle of 8 degrees, leads to a much lower, a much better under pressure in the chimney. Certainly for customers in India, I would recommend to also consider this possibility, because in India, the ambient temperatures are very high. 40 degrees is easily achieved, whereas the temperature of the flue gas is only 50 or 55 degrees in a wet stack. So there is very little natural draft, and there is a strong tendency for the creation of positive pressure, which is negative on many levels. By using this diffuser option, which is an added cost, of course, but a limited added cost, this type of overpressure, positive pressure will be avoided, and the draft in the chimney will be much better. It's also better for operating cost.
Okay. I'll just take 2-3 more questions. How do we select the thickness of PENNGUARD lining, that is where to use 38 mm and where 51 mm? How these thickness have arrived, and what is the selected as a standard?
Yes, so the standard, so if we are talking about the new chimney design, we are talking basically about a block thickness of 51 millimeters and adhesive thickness of 3 millimeters, so a total lining thickness of 54 millimeters. Now, cost is critical, of course, and some of our customers want to use 38 millimeters. It is possible in some cases, but it has to be carefully considered by our engineers. Of course, the thermal insulating factor of a thinner lining is a little bit less. So we have to consider carefully if the resulting stresses under all operating conditions are allowable for the concrete shell. I can say that historically, in some cases where a power plant uses only wet stack operation, no bypass, we have indeed allowed the use of 38 mm glass blocks, but it needs to be carefully checked. So basically 51, 38 is optional in some cases.
Next question is, sir, what is the installation procedure of the liner? Is the liner to be fixed in situ position? And quality control requirement, does it require insulation after fixing of liner in flue?
Yes. So this is, of course, more general for all of our projects, not only new chimney design, but also where steel flues are internally lined. For new chimney design, clearly it has to be applied to concrete, and so it can only be done in situ. For steel flues, there is an option to do it fully in situ after erection of the chimney, or to do pre-lined cans, where the chimney flue sections will go into the chimney with the lining already installed inside. So for the new chimney design, it's a very simple discussion. It's not possible to pre-line. You only can do it in situ. For steel flues, most of the time we recommend to do it in situ. Why? Because that makes it possible to install the steel flue and to take a lot of time, because typically it takes a lot of time, and only when it is ready, then the lining procedure will start. And also then HADEK's inspectors will come to site, because in order to have a good, effective lining, we must have fully supervised installation. So our inspectors are on the job site full-time during the installation of the product, and that is the only way how we can offer our 10-year guarantee. So just to summarize, in the case of a steel flue, you have a choice to do pre-lined or in situ, but usually we recommend in situ.
And is the cost a one-time cost for the new design chimney, or is the maintenance cost included in that, or is that separate?
It is a one-time cost. The maintenance cost for the first 10 years is fully included in our guarantee.
And sir, another question is that it may not be possible to arrange design quality of limestone for the entire life cycle of the plant. And in such case, how will we predict the intended performance of FGD, including quality of gypsum?
Right. Well, this is a very interesting question, and I'm happy that I am asked to talk about it because it's not directly a chimney question. Right. There are many things that can happen to a power plant between year 0 and year 30. We are always talking about the design that is on the drawing board and fixed and focused on that, like this is our only task. But in our company's philosophy, it is recommended to also think about the next 30 years and what can happen. You mentioned limestone quality. Definitely, it can be compromised sometimes, depending on the source. How about coal quality? Most power plants have strongly variable coal quality, and so something we are seeing with quite a few of our customers worldwide is that their flue gas volume is much different from the design, because when they go to a lower heating value coal, they end up putting a lot more flue gas through the chimney than what was originally designed. This has an impact on the chimney. First of all, the flue gas velocity can go much higher than planned. We have developed a special new technology for that, which we call the 45-degree high velocity pattern, which should be considered by customers if they expect that the coal quality could be less. Also, of course, we were just talking about the diffuser. Well, it is better to start with a chimney with good draft values than to have a marginal chimney, to build in some reserves wherever possible for these future hiccups, I would say, these future variations. That was my input on that point.
Right. On that note, we'll close the session, which has been a very informative session and a different, interesting format as well. I quite enjoyed it. I hope you did as well. We could not take all the survey questions. So what we'll do is that we will send you the actual results of the survey as well, so that you can get in touch with the participants directly.